All right, guys, so I have a bunch of problems that I'm going to go through to prepare you for your Chapter 13 test. So first one are those triangle problems. So I'm going to walk you guys through how to set up a triangle in the right quadrant and then how to find one of the missing pieces. So here's your first problem. I want you to find tangent of theta, and then you'll be given some criteria. So if cosecant is equal to 5/3, and you're in this quadrant. Okay, so you'll be given all of these pieces when you have one of these problems. You'll be told what to find, you'll be given one of the 6 trig functions, and you'll be given a quadrant. So here's what I want you guys to do. I want you to set up an angle in the appropriate quadrant, so between 90 and 180, here's 90, here's 180, so that's the second quadrant right here. So draw an angle in the second quadrant, and then make sure that your angle always goes back to the horizontal. So it should always be made with the line and the x-axis. Never ever put your angle here. That would mess up all your sides. Okay, so you can kind of drop down a little line, form a right triangle, so you know how to label all the pieces. So cosecant is 5/3. That tells you 2 of the sides that you can label. I purposely picked one that wasn't one of the main 3 functions so we could learn how to do that. So remember, sine and cosecant are reciprocals of each other. So sine is hypotenuse, opposite over hypotenuse, so cosecant is hypotenuse over opposite. So this is hypotenuse over opposite. That way you know what to label. So the hypotenuse is 5. That would be this side length right here. And then the opposite would be 3. So if this is theta, the opposite would be this side right here. So next thing is we need to use Pythagorean theorem to find the missing piece. So it's the x value that we're missing. So x squared plus 3 squared equals 5 squared. Okay, and then subtract the 9 from both sides. We're left with 16. And then when we square root, so like the x value that we have is 4. But technically, when you square root, you might have plus or minus. And it's actually the negative one that we want to take. So it's super important that you pay attention to what quadrant we're in. When you're in this quadrant, your x values are negative and your y values are positive. So since this represents the x value, it should be a negative side right there. Okay, so now we figure out what we're asking for. So tangent is the opposite over the adjacent. So from tangent, the opposite is 3, and then the adjacent is -4. So just to clean it up, like it's not super normal to put the negative sign in the denominator. You can, I won't mark it wrong. But all right, so that's how you do a triangle problem. We got that one. Next, you have some different things where you're verifying identities and simplifying things down. All right, so this is one that you'll have from 13.1. Here's another type of problem that you'll have from 13.1. You'll be asked to simplify a certain expression. Okay, so here's an example. When you're simplifying expressions like this, the first thing you want to do is, if it's not already sine or cosine, write it as sine or cosine. Okay, so cosecant is 1 over sine. That's one of your identities. Minus, and then tangent is sine over cosine. Okay, so what we want to do at this point is we want to be able to subtract those two, like one from the other, and so you need to get a common denominator in order to do that. So what I'm going to do is I'm going to multiply top and bottom by the same thing to make sure they do end up with the same denominator. So this one has the denominator of sine, which means we need to put sine into this one's denominator. So multiply by sine over sine. And then this one has cosine in the denominator, so this one needs to be multiplied by cosine over cosine. Okay, so we do that, then they're going to have a common denominator. So this is cosine times 1, so just cosine squared, and then over cosine times sine. Minus, and then multiply these, you get sine squared over cosine times sine. So these ones, when we combine these up, we're going to have cosine and then minus sine squared. And then over a common denominator of cosine times sine. So a lot of these will end up getting simpler when you simplify them up. This one is just as far as you can take it if we're writing it in terms of sine or cosine. There's really no other properties that would simplify down or do anything with this. So that's an example of simplifying. These are your 13.1 problems. Okay, so now moving on to your 13.2 problems. And 13.2 is all about verifying identities. Okay, so these ones you go through, your final answer is really just like your check mark when you've shown that you have simplified them down so that they're equal to each other. Okay, so first example, your directions from this section will always be to verify. So we are going to verify this property first. So one of the techniques that I gave you guys was to start with the more complicated side. So clearly the left-hand side has a lot more going on, so we're going to start there. And what we do is we rewrite everything in terms of sine and cosine. If it's already sine or cosine, then just leave it. So this side is much simpler. So we're going to go through this entire side and see if we can get it to equal the simpler side. So starting with tangent. Tangent is sine over cosine. And then times sine already is sine, so we're going to leave it. And then plus cosine. So I am testing out right now to see if it is in fact equal to secant. Okay, so order of operations says that multiplication comes first, so I'm going to multiply these two terms together. Think of this just as like sine over 1 in order to get them to multiply nicely. So I have sine times sine, which is sine squared, over cosine, and then plus just a cosine right here. And we're trying to find out if it's equal to secant. Okay, next, in order of operations, we want to be able to add these two together, and in order to do that, we have to have a common denominator. So I'm going to multiply this by cosine over cosine. So if I multiply by cosine over cosine, my numerator becomes a cosine squared, and then I add a cosine into the denominator. So now they both have cosine as a denominator, so I can add sine squared plus cosine squared, and then over my common denominator. And remember, like we've talked about so many times, sine squared plus cosine squared is equal to 1. That's called our Pythagorean identity. So we end up with 1 over cosine. We're wondering if that's equal to secant, and it actually is. That's just an additional identity. 1 over cosine is equal to secant. So our final line should look like this. You should have the left-hand side exactly the same as the right-hand side, and then that is how you know that you're done. Okay, so that's one example of verifying. Here's a second example of verifying. Okay, so I'm going to do with you guys 2 examples from each section, and that's what you guys will see on the test too. Okay, so with this one, the left-hand side is definitely the more complicated one again. So we're going to write everything that's not sine and cosine in terms of sine and cosine. So tangent, we write that as sine over cosine. And then cosine is already good. And cotangent, we write it as cosine over sine. Okay, and we're trying to find out if it is equal to, sine plus 1. Okay, so start with this. Think of this as like cosine over 1. I'm going to take this term right here, and I will distribute it to both of these pieces. So distribute here, and I get sine times cosine, and then just over cosine. Plus, and then do the same with this one, sine times cosine over cosine times sine. So that's my left-hand side. It still seems pretty messy, but I'm trying to find out if it's equal to sine plus 1. There we go. So you'll see that I have cosine over cosine, sine over sine, cosine over cosine. So anything, if it's all like within the same term like that, you can cancel. You couldn't cancel, say like this cosine with this cosine. That does not work. But what we end up with, so here we still have a sine left over, plus, and then here everything canceled, so technically you have a 1 left over, and now it's exactly the same as that other side. So it is in fact equal to sine plus 1. Remember how that's how you know that you have verified, once you get the 2 sides identical. Okay, so that's your 13.2 stuff. My next 2 examples, I'm going to go on to 13.3. This is the sum and difference formula stuff. So you've got 4 formulas that you should have on your note card. I'm not going to rewrite them just because you guys have the same notes that I do, but I'm going to just flash them up on the screen so you can see what I'm talking about. I said 4, I'm sorry, 6. So these are the 6 sum and difference identities that you have. All right, so 3 if you've got addition on the inside, sine, cosine, and tangent, same thing with subtraction. So those should definitely be on your note card. So let me give you an example. So on the test, I will say, like, use a sum and difference identity to find, and then something like the sine of 75 degrees. So notice 75 degrees, not something that's on your unit circle. All right, we jump right from 60 to 90, and we don't hit 75 in between, but we can write 75 as the addition of 2 different values that we do have on our unit circle. So we write sine of, we can split it up into 30 degrees plus 45 degrees. So 30 plus 45 is 75. 75 isn't on the unit circle, but 30 is and 45 is. Okay, so you guys have one of your formulas. I'm going to write down the particular one that I'm using. Okay, so you'd just be able to pull this right off your note card. And I'm just going to plug in my values that I have. So A is getting replaced with 30, so here and here. And then B is getting replaced with 45, here and here. So replace the A with 30, replace the B with 45, replace the A with 30, and again the B with 45. So now these four values, I'm just going to pull those right off of my unit circle. So start with sine of 30. So here's your unit circle. Here's 30. Sine goes with the y value. So that would be 1/2. Okay, and then cosine of 45. Here's 45. Cosine is the x value. So that's root 2 over 2. Okay, back to 30. Cosine, again, is the x value. And sine of 45. So back to 45. Sine is the y value. So that is root 2 over 2. So we simplify this up for our final answer. So 1 times root 2 is root 2 over 2 times 2, which is 4, plus root 3 times root 2 is root 6 over 2 times 2, which again is 4. So since we have a common denominator, you can go right ahead and add those together. We'd have root 2 plus root 6, all of that over 4, and that would be your final answer. So when you're told to find an exact answer, that's what it means. Not a decimal approximation, but something that actually looks kind of ugly like this and has a bunch of square roots. That would be an exact answer. Okay. Next thing you guys will be asked to do is to verify an identity using sum and difference formulas. Okay, so you had something just like this on the practice test. So we want to verify that this is an identity. Whoops, no parentheses there. Sorry, let me go here. Okay, and then again on the test, I will tell you, use a sum and difference formula to verify and then give you an expression like this. So this is the sum of a cosine. So I'm going to write that formula again just so we have it on the screen. So you've got 6 of them. Make sure that you have every single one of those formulas so you know what to reference. So that's one of them. So make sure that when you sub in A and B, that's going in as theta and 2 pi. So replace the A with a theta, replace the B with a 2 pi, replace A with theta, and replace B with 2 pi. So theta is just theta. Like that's going to be included in your final answer. But the 2 pi, those are unit circle values. So here is, this is also 2 pi. Your unit circle will definitely have that on there. I don't know why this one doesn't. And 360. So 2 pi is right here. Cosine of 2 pi is 1, and the sine of 2 pi is 0. So I just leave the theta. Cosine of 2 pi is 1. Leave the theta. And sine of 2 pi is 0. So this, I get cosine of theta times 1, which is just cosine of theta. And then minus sine of theta times 0. Anything you multiply by 0 just comes back as 0. So that's just cosine. So cosine theta equals cosine theta. We have just verified that identity as well. Okay, so that's your 13.3 stuff. Next, we're going to do a couple of examples from 13.4. Okay, so 13.4 is the half angle and double angle stuff. So this is our 7th problem. So we want to find the sine of 2 theta. If, and then you'll be given 2 pieces of information. You'll be given one of the 6 trig functions, and then you will be given a quadrant that the angle is in. All right, so we set that up. So first thing, know what you need, know what formula you're supposed to be using. So you can pull this formula right off of your note card. This is in your 13.4 notes. Let me just again show you that page so you know exactly what I'm talking about. It's the very first page of 13.4. So you've got these double angle identities right here. So this is the one that we're looking at. So 2 times sine times cosine. Okay, so here's how you do a problem like this. You have sine. Sine theta is 3/5. Like that is just going to go right here in our formula. But we don't have cosine. We need cosine. We can set up a triangle in order to get cosine. So we have something just like that with the first one that I did for you guys. So start with your quadrant. Going to set up an angle in the appropriate quadrant. Remember, it always goes back to the x-axis, never ever the y-axis. Turn it into a right angle. So I know that the sine is 3/5. So from theta, remember sine is opposite over hypotenuse. So I have the opposite and I have the hypotenuse. So you might notice that this is a 3, 4, 5 triangle. And it is. As long as the hypotenuse is 5, you can do a 3, 4, 5 triangle. So this is 4, but we would make it -4 because it's in the second quadrant, so it goes off to the left. This is actually the exact same triangle we ended up with in the first one that I just did for you guys. So we've got sine. We need cosine in order to fill this all into our formula. So cosine of this angle, remember cosine is adjacent over hypotenuse. So adjacent to the angle over the hypotenuse. Okay, so now that is going to go in right here into our formula. So here's what our final answer would look like. We've got 2 times the value of sine, which was given to us, that's 3/5, and then times cosine, which we just found was -4/5. So we multiply all that together. Think of this as 2/1. You'd have 2 times 3 times -4, that's -24, over 1 times 5 times 5 is 25. So that would be your answer, would be this fraction right here, -24/25. Okay, so that's a double angle formula. You also have really similar formulas for tangent and for cosine, if those were to pop up. Second question for 13.4, we're going to be dealing with our half angle formulas. So let me show you. Here they are on the top of that next page. So you've got 3 half angle identities. So let me show you what a sample problem would look like for that. I would tell you, something like find cosine of the half angle, or sine, or tangent. I could question you on any of them. And then I'll give you some info. I'll say if sine of theta equals -12/13, and then I'll give you the quadrant that I want them to be in. It's like that. Okay, so start with the formula. Know what you're looking for, know what the formula is. So this formula comes right out of your notes, and you should have it on your note card. It's this. Okay, so notice, in our formula, we need cosine. We don't have cosine, we have sine. So we're going to set up a triangle, just like we did up above. So set up a triangle. This time it's going to be in the third quadrant, between 180 and 270. So put our angle somewhere in there. Make sure it goes back to the x-axis, never back to the y-axis. And then make yourself a triangle. So take a look at these measurements. Sine is opposite over hypotenuse. So from theta, the opposite is -12, and the hypotenuse is 13. The hypotenuse is the diagonal, and it's always positive. It doesn't matter what quadrant you're in, it's always going to be positive. So we just need this piece right here. Pay attention to the fact that since we're in the third quadrant, this leg is negative, and then this leg is also going to be negative. All right, so plug everything in. It's the x value that we need to find, plus, and then if I square the -12, I get 144. And if I square the hypotenuse, 13, I get 169. So I'm just going to solve for that last piece. So subtract 144 from both sides, and that leaves me with 25. And then square root. So remember, when you square root, you technically get plus or minus 5. Could be either one, depending on whether you're going left or right. And since we're going to the left, we're going to label it as -5. All right, so like I said, we need cosine for our formula. So let's figure out what that is. So cosine, we've got from the angle, cosine is adjacent over hypotenuse, just like that. So now this value right here can get plugged into our formula. So that's what we're going to do. So cosine of theta over 2 equals plus or minus. We'll figure out the plus or minus in just a second. Big square root 1 plus, and the cosine value, we just figured out the cosine was -5/13, and then over 2. So I just took this value right here and replaced cosine in the formula. So 2 things left to do. I need to figure out the plus or minus, and I need to get rid of this horrible fraction within a fraction thing that I've got going on. So whole numerator, whole denominator. Since I have a little denominator of 13, what I'm going to do is multiply top and bottom by 13 to get that to clean up a little bit. So big square root again. Multiply both of these by 13. So I will get 13 times 1, which is 13, minus, and then 13 times 5/13. These 13s would cancel, and I just have a 5 left over. And then 2 times 13 is 26. Okay, almost done. So let's talk about the plus or minus. So back up to my angle. If my original angle is somewhere between 180 and 270, I can figure out what my half angle would be. So just cut these both in half. So half of 180 is 90. Half of 270 is 135. So if my angle is somewhere in this range, this is in the second quadrant. Okay, so if my angle is in the second quadrant, cosine actually comes back negative when I'm in the second quadrant. So I definitely want my answer to be negative. 13 minus 5 is 8 over 26. I'm just going to keep reducing this. So negative, they're both even, so you can reduce them down. 4 over 13. And split them up. Square root of 4 is 2. I don't know the square root of 13, but I know that I can rationalize. Okay, so there you go. So that's your half angle, double angle stuff. The only thing that's left is our equations from 13.5. So I've got 2 examples of those. Okay, we're going to do 1 GCF, 1 normal factoring, and 1 will be in radians and 1 will be in degrees. So we get kind of a little variety of everything. Wait, sorry, that is minus. Okay, so 2 sine squared minus sine minus 1. Sorry, I was looking at the wrong thing on my notes. All right, so I'm going to write that one more time just so it's clean. And we're going to factor that down because it is a quadratic. So when you have a quadratic, you factor it into normal, like parentheses, parentheses like this. So start with this term. So in order to get 2 sine squared, these 2 terms would have to multiply to give me sine squared. So I know there's going to be a sine in sine. That'll give me the sine squared. But then I'm going to have a 2 and 1 to give me the 2. So 2 sine, and then just 1 sine. Okay, so if I multiply these together, I'm getting my leading term here. So this is where we do like the guess and check method. So minus 1, these 2 are supposed to multiply to negative 1. So it's either minus 1 here and plus 1 here, or minus 1 here and plus 1 here. It ends up being minus 1 here and plus 1 here. Okay, so we went through a couple of these in class with the guess and check method. If you guess and you guess wrong, you're just looking to make sure that you end up with your middle term here. So if you check your middle term, the outside gives me negative 2 sine, the inside gives me positive 1 sine. That's how I know I got it right. Okay, so this is how I factor it down. Remember, what you do next is you take the 2 pieces individually and set them equal to 0. Like that. And then we do whatever we need to get the sine part by itself. Okay, so here, if we want the sine part by itself, we would do that by subtracting this 1 and then dividing both sides by this 2. So we get that. And then the second one, we get sine by itself by just adding this 1 to both sides. So these are the values that we're looking for on the unit circle. We want any values of sine that are equal to negative 1/2, and we want any values of sine that are equal to 1. So when we're looking on the unit circle, remember y goes with our sine values. So if we want sine of negative 1/2, we're looking for y values of negative 1/2. So if we look all the way around, start looking at our y values, these are all positive. Here are the negative ones. There's a negative 1/2. So that'll be 210. And then there's another negative 1/2. So 330. So 210 and 330. So we get theta equals 210 and 330 from our first one. I should have mentioned that I wanted this one in degrees, and I will tell you that on the test, whether I want degrees or radians. And then this one, where sine is equal to 1. So now we want a y value of 1. So just start looking at the y values. There's 1, so 90. And that's it, just 1 more, so 90. So these are your answers in degrees. Okay, last one that we're going to look at. You'll see another one where you have to use the Gcf method. All right, so Gcf would look something like this. Okay, so this doesn't factor in the traditional sense because you don't have like the 3 separate terms like this, and this isn't just a constant. So this actually does factor by a Gcf. So I would say always look for a Gcf first. See if you have 2 separate terms and they have something in common, factor it using the Gcf method. So both of these terms have a cosine in common. So you can factor that out, and then you'll write the leftovers in parentheses. So when I divide this one by cosine, I'm left with another copy of cosine. And when I divide this by cosine, I'm left with 1. Okay, so just like up above, this is now 1 factor, this is 1 factor, and this one we want our answer in radians. So I'll give you one of each on the test, and I will tell you. So take cosine and set that equal to 0, and set cosine plus 1 equal to 0 as well. So I want values of cosine that are equal to 0, so I'm going to look on my unit circle. According to this one, I want values of cosine equal to -1. So just subtract the 1 from both sides to get that cosine by itself. So we want cosines of 0 or -1, so in radians as well. Back to the unit circle. Remember, cosine goes with my x values, so either 0 or -1. So start looking at x values. There's 1, so pi over 2. There's -1, so pi. There's the 0 again, so 3 pi over 2. So just 3 values. Here, cosine is 0, so pi over 2 and 3 pi over 2, and then here it's -1, so we got pi. So pi over 2, pi, and 3 pi over 2. Make sure you're being careful in giving them in terms of radians or degrees depending on what I ask for. So 10 questions, just like you'll see on the test, 2 from each section, and I hope that was helpful.